In this video, I'm going to explain merge sort. Merge sort follows divide and conquer strategy. Divide and conquer method means first of all we have to divide the array into two sub-arrays. Afterwards, again sub-array also we have to divide until the list is having only one element. That is the first step in merge sort, division. We have to divide the array into sub-arrays. So until the sub-array is having only one element. And after that, we have to sort and merge the arrays. So finally, we'll get sorted array. So first of all, we'll see how to divide the array. So this is one example. And array index starts with 0. 0, 1, 2, 3, 4, 5, 6, 7. So total there are 8 elements. The first element index starts with 0, then last element index ends with 7. Okay, so division means based on mid we have to divide. See, for example, the first index I am going to assign to low, the last index I am assigned to high. Now, we have to calculate the middle element. Based on the middle, we have to divide the array into two sub-arrays. So, how to calculate mid? So, mid equals to low plus high by 2. So, here low is 0 and high is 7. 0 plus 7 by 2. 7 by 2 it is 3. So, now mid equals to 3. So, low to mid, and we have to store low to mid values in one array. We have to divide like this. Now, one array will contain the elements from low to mid. In another array, we have to store elements from mid plus 1 to high. So, like this, we have to divide. See, in this example, mid value is 3. So, low to mid. So, all these elements we have to store in one array. See, 22, 45, 97 and 36. Okay, the remaining elements. Remaining elements are means mid plus 1. So 3 is mid. Mid plus 1 means fourth element. That is 19, 38, 17 and 25 is high. Like this we have to divide. Calculate mid. Mid plus 1 low to mid in one array, and mid plus 1 to high elements we have to store in another array. So, we are not changing index values. So, index as it is 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now, again this array, again we have to divide it into two sub-arrays. Now, in this array, the low value is 0. High value is 3. So, 0 plus 3 by 2 it is 1. So, this is mid. So, in one array, we have to store low to mid elements. It means 22 and 45. And mid plus 1 to high means 97, 36. In right side array also, same like that, we have to divide low, high and mid. So, 4 plus 7, it is 11 by 2, that is 5. So, again divided into two sub-arrays. 1938 in one array, 17 and 25 comes to another array. Now, in this array, this is low and this is high. Again, low is less than high. See, until the list is having or until the array is having one element. So, have to check the array is having only one element means if at all low is less than high, it means that the list is having more than one element. See, now the low is less than high. Array is having more than one element. So, again we have to divide. Again calculate mid. How to calculate mid? Low plus high by 2. 0 plus 1 by 2. So, 0 plus 1 by 2. 1 by 2 means it is 0. So, this is mid. Okay. Low to mid means only one element. That is 22. Mid plus 1 to high means only one element. That is 45. Now, there is only one element. If there is only one element means low is 0 and high is 0. Here also low is 1, high is also 1. If at all low is less than high, it means the array is having more than one element. Low equals to high means there is only one element in the array. See, if low is less than high, then only we have to divide. Otherwise, no need to divide. Like this, until the array is having one element, we have to divide. See, like this, we have to divide array elements. Have to write a code for this division. Okay, first in main function anyway we have to read array elements, read array size and array elements. Okay, and now I'm going to call merge sort function. So initial index is 0 and the last element, first element index, and I'm going to send the last element index. This is main function. After sorting, again before sorting, after sorting, you can print the elements. So only the important statements I'm going to explain. The remaining statements everyone can write. So reading part and this is also after merge sort, you can print the array elements. Okay. Now in merge sort function, we'll divide the elements. This is merge sort function, and for merge sort, we are sending two elements. So the first element index assigned to low, and the last element index is assigned to high. Okay, this is merge sort function. So low and high, and first we have to calculate mid value. Okay, now so if low is less than high, then only we have to calculate. If low is less than high or low is not equals to high, then calculate mid value. Mid equals to low plus high by 2. So like this we have to calculate mid. And next, repeatedly we are doing same thing. So until the list is having one element, we are calculating the mid value and we are dividing the array into two sub arrays. So repeated task we are doing. So I am going to call same function. So merge sort. So based on mid, we have to divide the array into two arrays. Again, this array also we have to divide. Again, this array also we have to divide. Means same task we are performing. So again, I am going to call merge sort function. So have to divide the array. So low to mid and mid plus 1 to high. So merge sort of low to mid. And again, merge sort of mid plus 1 to high. See, merge sort of low to mid. If we take same example, here the low value 0. Okay, and mid value it is 3. So merge sort of 0 to 3. So 0 to 3 again. 0 will be assigned to low and 3 will be assigned to high. Again it will calculate mid. So repeatedly it will perform this task until the low is less than high. So once low is equals to high, then simply it will exit from that one. So like this, using recursion easily we can write the code. This is for division. After division, we have to merge, means we have to sort and merge. So for that I am going to call merge function. For merge function, I am going to send low, mid and high. Based on low, mid, high, we can sort the elements. So this is about merge sort function. This is division. So initially, first low value and high value. The first element index and last element index, we have to send it to merge sort function. The first element index will be assigned to low. The last element index will be assigned to high. See, if low is less than high or low is not equals to high. Anyway, you can write it. So, it means that the array is having more than one element. If the array is having more than one element, we have to divide the array. Have to divide array based on mid. Calculate mid and merge sort of low to mid will placed in one array. And in another sub array, what we have to place remaining elements means mid plus 1 to high. And again, if the array is having more than one element, again we'll call merge sort function divide. Again call merge sort function divide. Okay, like this we have to divide. After division, it will call merge function. So in merge function, we have to sort and we have to merge. So we'll see how to sort and we'll merge the elements. After division, we'll see how to sort the elements. So first of all, we have to sort these two numbers, 22 and 45. So anyway, 22 is less than 45. So after this, sort these two elements. After sorting also, we'll get as it is, 22 and 45. Next, we have to sort these two elements. 97, 36, which is smallest element 36. So 36 will be placed in second position and 96 will be placed in third index. So 36 after sorting 97. See, these two also after sorting, anyway 19 is less than 38, so 19, 38. Again, these two elements 17 and 25. Okay. Now these two arrays, these two are sorted arrays. All these four are now sorted arrays. Now we have to sort these two arrays, then these two arrays. So first of all, we have to sort these two arrays, 22, 36. Which one is the smallest element? 22 is the smallest element. Afterwards, 45, 36. 36 is the smallest element. Now, remaining 45 and 97. Which one is the smallest element? 45. The next element it is 97. Just to keep on sort and merge until we'll get sorted array. So now we have to sort these two arrays. So when we sort these two arrays, we'll get 19, 17. Smallest element is 17. Now 19, 25. Now 19 is the smallest element. Now 38 to 25. 25 is the smallest element. Then 38. So now again we have to sort. Finally we have to sort these two arrays. 20 to 17. 17 is the smallest element. After this 20 to 19. 19 is the smallest element. Then 22, 25, 36, 38, 45 and 97. So finally like this we'll get sorted array. So until this is division method. So after dividing arrays, means after dividing the array into sub arrays, until the sub array is having only one element, so continuously we have to divide, and after division we have to sort the elements. We have to sort until we'll get sorted array. So like this, sort these two elements, afterwards sort these two arrays. So like this we have to sort the elements. So we'll see code also how to sort these two elements, which element we have to compare. This is one sorted array, this is also sorted array. How to sort these two sorted arrays, which elements we have to compare. So I'll explain clearly with the example. So if there is only one element, 22 and 45. So this is 0th position, it is in first location. So if which one is the smallest element? 22. So no need to swap anything, directly we'll get 22 and 45, because 22 is less than 45. Only one comparison we have to perform. If 22 is greater than this element, then this one will be placed first. So if there are two elements, easily we can sort. So we'll take one more example. So after sorting these two, we have to sort these two arrays. Now I'm going to take these two. 22, 45 in one array. In the another array, the elements are 36 and 97. Index values are 0, 1, 2, 3. Okay, we'll see how to sort these two sub arrays. First of all, 22 is compared with 36. The first element in this array, the first element index is assigned to I. In this array, the first element index is assigned to J. For example, array name is A. Then what we have to compare? A of I, A of J. First element in this array, first element in another array, we have to compare. Now, A of I is less than A of J. Okay, less than or equal. If A of I is less than or equal to A of J, then that smallest element we have to place in one temporary array. After storing in temporary array, later we can copy to A array. That is very simple. Now, 22 is less than 36. Now, 22 I am going to copy to one temporary array. So, now ith element we have compared, ith element we have already copied into this array. Now, which element we have to compare? The next element. It means we have to increment only I. Because only ith element we have copied. So, increment only I, not J. When you copy J, then increment J. Now, again compare. A of I is less than A of J? No. A of J is less than. Now, which element we have to copy? J then. Which one is the smallest element? Ith element or jth element? That copied into temporary array. Now jth element is smaller than ith element. So 36 we have to copy. Now after this increment j value. Now again compare ith element, jth element. Oh, now ith element is smaller than this one. 45 is less than 97. So I am going to copy ith element 45. Now increment I value by 1. Now, is there any ith element for comparison? No. So you cannot compare with jth element. But in this array, these two already we have copied into temporary array. But in this array, one element is left. In this array, that element also we have to copy into temporary array. So later everything we can copy into same original array, that is A. So see, in 0th location the element is 22, 36, 45, 97. So we'll take one more example. First element, this index assigned to I, this index is assigned to J. Again compare, ith element or jth element? Jth element is smaller. So 17, increment J. Now ith element is smaller. Increment I. Now which one is smaller? Jth element. 25, increment. Now for comparison, there is no jth element and everything we already we have copied from this second array. In first array, one element is left. So this element also we can copy. Okay. So did you remember how we have divided the array? This is the first, based on mid value only we have divided. In one array we have placed elements from low to mid. In another array, mid plus 1 to high elements we have placed. So this is low. In this example, low is 0 and mid is 3 and mid plus 1 is 4 and high is 7. So like this we have divided. I have written same array again. See, low value is 0. This is low. This low value is assigned to I. And in this array, the first element index is assigned to J. The first element index means it is mid plus 1. So mid plus 1 is assigned to J. Okay. Now we have to compare ith element, jth element. See, A of I is less than or equals to A of J. Then A of I is copied to temporary array. Okay. Now T of K plus plus equals to A of I plus plus. See, ith element is copied to one temporary array. So every time, so here we are not using any for loop. So every time in next position we have to store. For example, this is one temporary array. 22, which one is a smaller element, smallest element, 22 or 17? 17. The next element I have to store in next location. That is the reason every time we have to increment the k. K is index for this array. And ith element we have to copy it. See, afterwards when we copy ith element or jth element, immediately that value is incremented by 1 because we have to compare the next element. So instead of writing 3 statements, I have combined in single statement I have written. So T of K equals to A of I, then you can increment K plus plus I plus plus. So instead of writing 3 in single statement, easily we can write. So if at all A of I is less than or equal to A of J, A of I will be assigned to T of K. Else it means that A of J is less than A of I, then T of K plus plus equals to A of J plus plus. Jth element we have to copy. See, now ith element is less than J? No. Jth element is less than I. So jth element just we have to copy into temporary array, that is 17. Okay. Now afterwards increment J value by 1. Anyway it will increment K value. Means in next position only it will store the next element. Again ith element as it is 20 to 19. Smallest element is 19 only. Again increment J. Now ith element is smallest element 22. Increment I value. Now 25, 36. 25 is the smallest element 25 and increment J value. 36, 38. Ith element is the smallest element 36 and increment I value by 1. Now ith element 45, jth element 38. Which one is the smallest element? Jth element. So 38. I am going to assign 38. Now increment J value. Now, can you compare jth element and ith element? J is out of index. There is no element at jth position. So we cannot compare. It means that J is out of index. If it is out of index, you cannot compare. When, see, repeatedly we are comparing this condition. I is less than J or J is less than. Repeatedly we are comparing until how many times we have to compare? Until some condition becomes false. If you can compare the elements, okay, fine. Now, can you compare? Because there is no jth element. Now you cannot compare. It means that what is the last index? That is high. So if at all j is less than or equal to high, then only you can compare jth element. In this array also, this side also, if I is less than or equal to mid, see this is mid, I less than or equals to mid, then only you can compare ith element. It means I is less than or equals to mid and j less than or equals to high. If the condition, this complete condition is true, then only you can compare this one. See, repeatedly we are comparing these two conditions. So I'm going to write in one loop while. See, while I less than or equals to mid. And one more condition, j less than or equals to high. If these two conditions are true, then only you can compare ith element and jth element. Otherwise, we cannot compare. See, coming to this example, now I less than or equal to mid? Yes. J less than or equals to high? No. Now J is greater than high. So, this it becomes false. If one is true and false, total condition becomes false. Simply it will exit from while. So now have to copy remaining elements. So sometimes few elements may be left in first array, sometimes it may be left in second array. So individual array we have to check. It means elements left in first array or elements left in second array we have to compare. Means individual array you have to take it, you have to check everything copied from first array or everything copied from this array or not, we have to check. So first of all I am going to take this one. So I'm going to check everything we have copied or not. See, have to check means while I less than or equals to mid. See, now I less than or equal to mid? Yes, it means that few elements are left in this array which are not copied into temporary array. So now directly, now no need to compare with, because there is no jth element, no need any comparison. Directly ith element you can copy. What is ith element? 45. Okay, 45 you can copy and increment I. See, while I less than or equals to mid, this a of I is copied to t of k and increment I value. Now again, now I less than or equal to mid? Yes. Again, ith element you can copy 97 and increment I. So it means repeatedly you have to compare. Now again I less than or equal to mid? No. Now it is greater than. So it means that now everything we have copied into temporary array. Same way we have to check the second array also. In this example everything we have copied. But anyway we have to check. So sometimes it may be left in this array also. So I have to check while j is less than or equals to high. If at all j is less than or equal to high, it means that few elements not copied from this array into temporary array. So you can copy t of k plus plus equals to a of j plus plus. Like this, individual array also you have to check. Individual array or individual list you have to check, and you have to copy the remaining elements into this array. So once we copied everything, then all temporary elements you can copy into, from temporary array you can copy it into a array.